Alright, so in this video we're going to learn about angle of elevation and depression, which is going to be fun because we're going to be able to draw things from now on. So again, this is not in your notes, but this is a good visual of angle of elevation and depression. So here's a dog looking out. That's going to be his eye level, okay? Now the dog's going to look up at something, and that right there is going to be the angle of elevation. So that's how much the dog or person or whatever had to lift up their head to see another object, okay? Now you've got a bird. Here's the bird looking out. That's going to be its eye level, okay? Now the bird's going to look down and see something. So the angle right here from where the bird was looking to where it's looking now is called the angle of depression. So depression means down, elevation means up. So you've got a bird and you have the dog. Here are their eye levels, and then they see each other, okay? So you've got the angle of depression and you have the angle of elevation. Guess what? They're the exact same angle, okay? Because the angle at which the bird looked down and the angle at which the dog looked up and made eye contact is going to be the same. So the reason that is you've got parallel lines, okay? Because your eye level is going to be parallel. You're both looking straight ahead. So you have alternate interior angles, okay? So angle of depression is always going to be the same as the angle of elevation. So if you don't like angle of depression, always do angle of elevation, okay? They're going to be the exact same thing. All right, so let's look at some examples. So in our angle of elevation, this line right here is going to be called the horizontal line. Okay. And then from the person looking up at the hot air balloon, that's going to be called the line of sight. So that means this angle formed is going to be the angle of elevation. Okay. So now if I looked at the hot air balloon, this is going to be my horizontal line. Remember, horizontal is going to be flat. The air balloon looking down at the person is going to be your line of sight. And that means this angle is going to be the angle of depression. Okay? So basically you've got your line of sight connecting is going to be the hypotenuse in a right triangle. Because if I were to draw a right triangle like such, I can find a missing side. Same thing with depression. You could draw your triangle like straight down, or you could even draw your triangle on the outside. It's up to you, okay? So first off, you are going to be given 3 pieces of information, and you're going to have to find a missing piece. So you could be given how far away the object from the viewer is. You could be told what the altitude is from the ground to the object. Okay, so if it asks for altitude, that means up and down. And then you could be asked what the angle is between the line of sight and the horizon. So basically, can you find the angle of depression or elevation? So first step is to draw a picture. Have so much fun with this. Step 2 is to label all the information, and then step 3 is to determine which trig ratio to use, and then set up and solve. Okay, so let's look at some examples. Make this smaller for us. So we're going to use the round to the nearest foot, 100th of a foot, for sides, and then round to the nearest degree for angle. Okay, so you will not be given pictures all the time, and the hardest part is drawing the picture on their own. Obviously, if they give you a picture, it's going to be pretty easy. So you've got a hiker down here standing 220 feet from the base of a hill. So if this is your base, that means that 220 is going to be on the bottom. Base means bottom. The angle of elevation, so from where he is standing, is 29 degrees. And then how tall is the hill is what we're trying to figure out. So that's going to be X right here. How tall is that hill? So first off, I'm going to label my triangle. So this is going to be my opposite side. This is my hypotenuse and my adjacent side. I don't know anything about the hypotenuse in this case. So what deals with O and A? That would be tangent. So I'm going to set up tangent of my angle, which is 29. So tangent is opposite over adjacent. And x is down low, so I'm going to cross, or x up high, cross multiply. So do tangent of 29 times 220. Again, make sure your calculator is in degrees, and you should get 121.947. So that's going to make, the 7's going to make that a 5. So 121.95, and are we in feet? Yes. So that hill is basically 121.9 feet tall. How cool. All right, on number 2, you have a 30-foot ladder that forms an angle of 50 degrees with the ground when placed against a brick wall. So, if you have ever seen a ladder, let's say this is our brick wall, this is our house, and you've got some ladder that is tilted up against it. Okay? And here's the ground. So, I noticed that building and makes a right angle with that ground. Okay? And the angle formed with the ground was 50 degrees. Okay? How far up the wall will the ladder reach? So I'm looking for how far up, and then I do know that it is a 30-foot ladder. Okay? And then I also want to know how far away from the base of the wall is the ladder. So I need to find x and y in this case. So first off, I'm going to see how far up the wall it is. I'm going to label my triangle. So this is opposite of 50. That is my hypotenuse. And that means y is going to be adjacent. So if I'm looking at O and H, that would be sine. So sine of 50 is going to equal x over 30. So I'm going to multiply those and get sine of 50 times 30. So let's do that in our calculator. And you would get, it's going to be 22.98 feet up the wall. And then let's do another problem and find how far is the ladder from the base. So I would be now using A and H. Okay, it's better to use the hypotenuse because it's very exact, because the opposite of what we just found was rounded. So I'm going to do cosine of 50 equals adjacent, which I don't know, over hypotenuse. So I'm actually going to call that y. So again, my variable is up high. I'm going to cross multiply. So cosine of 50 times 30. So I get 19.28 feet. So that is how far from the base of the building the ladder is. Okay? All right. Let me know if you have any questions on that one. Otherwise, we're going to look at number 3. So you have Alex standing on the ground and looks up to see a plane flying in the sky. So we got a ground. Here is Alex. And he's going to be looking out, and he's going to find a plane up in the eye. So let's draw a plane. Let's draw windows on it. Okay. I am no artiste. If it is flying at an altitude of 2 miles. So remember, altitude is how far in the air something is. So it's got an altitude of 2 miles up in the air. So there is my right triangle formed. And the distance along the ground is 5 miles. So this distance right here is 5 miles. What is the angle of elevation that Alex has to look up? So I am looking for how far he looked up to see that plane in the air. So I need to label my triangle. So this is going to be my hypotenuse. and this is going to be opposite, and that will be adjacent. So I'm dealing with O and A, which is tangent. So tangent of the angle that I don't know is going to equal opposite over adjacent. So I'm going to do the inverse tan of 2/5. So let's type that in the calculator. Inverse tan of 2/5. Again, make sure your calculator is in degrees. You would get 21.8 degrees, and so we're going to round that to 22 degrees since it's a degree. So Alex is going to have to look up 22 degrees to see that plane flying in the air. Okay? All right. We're going to do one more angle of elevation problem, and then we'll move on to depression. So you've got Michael, whose eyes are 5 feet off the ground. Now this is important. If they tell you how tall it is from the foot to someone's eyes, your right triangle is not going to be flat on the ground. Okay, so we're going to have to do a little bit more math on this one. So his eyes are 5 feet off the ground and is standing 30 feet away from a building. So this horizontal distance is 30 feet from a building, and he's looking up at a 50-degree angle. How tall is the building? Okay, so I pretty much know that this distance right here is 5 feet. And I'm basically trying to figure out how tall this is. So I'm going to have to figure out the part of the building that he can see and then add on to what he can't see below him. So I'm going to ignore that 5 feet for right now and know that I am looking for opposite. This is my hypotenuse, if that's my right angle, and that means this is adjacent. So opposite and adjacent is tangent. So tangent of 50 is going to equal opposite x over adjacent, which is 30. So x is up high. I'm going to cross multiply. So tan of 50 times 30. So the building that he can see is 35.75 feet. Okay? But I also have this piece that he can't see. So you're going to have to add in your eye level. And so my total will be 40.75 feet. So that is how tall that building is. So notice on number 3, they did not give us an eye level, so I didn't have to add anything in. But if they do give you the eye, or how far it is from the foot of the ground to someone's eye level, you are going to have to add that in. Okay? So those are how you do angle of elevation problems. Now why don't you go ahead and watch the second video on angle of depression problems, okay?